All right, CEN100 class. I will be here before the end of class, but I knew you would miss me terribly, so I decided to make this little video for you. Thought it would be a little more interactive than, me just telling you what's going on today. So, and I also knew that you'd miss my lovely face, so I took a nice picture that Ken, who's leading the class, took a while back of me, and so there's my nice smiling face, just in case you missed it. Another note is that everything's graded on Blackboard up to this point, so your grade's up to date, so you know how you're doing. If you're not doing well, see me. Um, Other than that, you know also that your quizzes, almost all of them are, you can take your individual ones, you can take over and over again before the due date, so make sure to take advantage of that. That's the easy way to boost your grade. All right, so what are we going to do today? I'm going to go over a little unit conversion overview with you. Then you're going to do some sumo bot building. You're going to be working on your group quizzes LSB 5 and LSB 6. Those are due by the end of class. So LSB 5 isn't too bad. LSB 6 gives some groups some trouble, so make sure you work diligently on that. The big thing is we're having our first competition next time at the start of class. So you need to be completely ready for the competition. Completely. Okay? So remember, there's no modifications to the robots except adding sensors. So you can add as many sensors as you want, but no other modifications. Your group quiz LSB 7, that's your competition program, and that's due before class next time. Okay, so now, the other big thing is you're going to have a unit conversion quiz at the end of class, just like last time. So make sure you pay attention to what I go over in this video. And then the other big thing is, remember, another individual quiz on unit conversions online on Blackboard ES3 is due before next class. Okay? So again, you have unlimited attempts with that, so take your time and do well with that one. Okay. So let's go ahead for unit conversion. The factor label method or dimensional analysis is the biggest way you can do some unit conversions and also solve some word problems. And there's 4 steps. Express the given quantity as a fraction, and then insert some conversion factors, and then cancel the units, and then solve the math. So let me show you how it works in practice. So let's look at our first problem. Let's just convert 5 feet to inches. So this should be a pretty easy problem for all of you to do. But this is how we're going to write it out. We're going to write 5 feet over 1, and then any conversion factor, we write 12 inches equals 1 foot. So we can just write that over each other as divided by. So 12 inches over 1 foot. So why we put 1 foot on the bottom is because then foot cancels with feet. If we wrote 1 foot over 12 inches, we could do that, but the feet wouldn't cancel out. So they have to be top and bottom to cancel out. Okay, so now that we cancel it out, the only units left are inches. That goes to the right-hand side. And then we just do the math. 5 times 12 equals 60. All right, so let's try 200 pounds to kilograms. There's 2.2 pounds in 1 kilogram. Same type of idea. 200 pounds, except now we have 1 kilogram on top and then 2.2 pounds on the bottom. Okay? Again, we cross out the units. This is what I'm going to be looking for. Crossing out units. Always do that. And then we're left with kilograms, so that's what's on the right-hand side. Let's try one more. So this one's a little bit more complicated. So now this is 20 miles per hour to feet per minute. Okay? And they're 5,280 feet per mile. So we start with 20 miles per 1 hour, and then we're trying to cancel out, get rid of the miles, and end up with feet. So we write 5,280 feet per 1 mile. So that's what's going on there. And then we're trying to get rid of the hour and go to minutes, and we know there's 1 hour and 60 minutes, so that's why we do that. And so then we do the math. We do 20 times 5,280 divided by 60, and that gives us 1,760 feet per 1 minute. Okay? So that's how we do this. So let's keep going. Let's try another one. So 50 meters to kilometers. So we know kilo, remember, is 1,000. So that means there's 1,000 meters in a kilometer. So same thing. So the only thing I forgot to do here was cross out the meters. And I really want to stress that. And then 20 miles per hour to inches per second. So we do the same thing, 20 miles per hour. And we do the same thing with feet, but then we insert another unit conversion to go from inches, or to go from feet to inches. And then the same thing with hour and minutes, but then we need minutes to seconds. Okay? So this is sort of how you solve these types of unit conversion problems. Okay? And this is not just, I'm not just pulling this from anywhere. This is going to help you solve some real world problems, and the next slide is going to show you this. So this is a real world problem, and it's also going to introduce areas into dimensional analysis. So the picture to the right is the largest solar power facility. It's in the Mojave Desert in California, and it's going to be 3,500 acres. What we want to figure out is how big is that going to be in square miles. Okay. So 1 acre is 43,560 square feet, and 1 mile is 5,280 feet. So what I'm going to show you is a common mistake here. So you get 3,500 acres, that's what we're starting with, right? And then we know there's 43,560 square feet per 1 acre, so we can cross that out. And then we know there's 1 mile and 5,280 feet, so the feet cross out with square feet, and that's 28,875 square miles. So I'm telling you this is wrong, but why is this wrong? Square feet and feet do not cancel. Let me repeat that. Square feet and feet do not cancel. So what we have to do is remember that square feet is feet times feet. So if we do this, if we look from here over, we see that's the same thing, but that only cancels out one of the feet. So we have to do this twice. We have to do the unit conversion from miles to feet twice. And when we do that, we get 5.47 square miles. Okay, so I want to go over another example for unit conversion just to show you that, again, it can be some real world problems. And we're going to do hybrid cars versus conventional cars. I'm not going to go over how they work, but I posted some cool videos here if you want to take a look. This presentation will be posted on Blackboard. And again, if you want to take a little look about how hybrid cars work. The basic idea about hybrid cars is that they have higher miles per gallon. Okay, so what we're going to do is a little problem. How much more money does it take to fuel a conventional car, 23 miles per gallon, over a hybrid car, 33 miles per gallon, for the lifetime of the car? So our assumptions, we're just going to assume that a car lasts 180,000 miles and that we spend $3.50 per gallon. So the first car, the 23 miles per gallon car, we multiply by $3.50 per gallon. So again, gallon is on top because we have to cancel it out on the bottom. And then we know one car lifetime equals 180,000 miles, so that gets rid of the miles. And so what we have here is we do the math out. We do 23 divided by 350, 3.50 divided by 180,000. We get this weird unit. We get the 0.0000365 car lifetime over dollars. What we really want is dollars per car lifetime. So what we do is we take 1 divided by this top number, and that flips it. So again, we take 1 divided by this top number, and that flips it to $27,391 per car lifetime. We do the same exact thing for the 33 miles per gallon, and we get $19,000. If we take the difference between these two, that's an $8,300 difference. So you can see this could be a real calculation that you might want to do when you're buying a new car, if you want to take into account miles per gallon, because it can be a real big difference. So again, like I said, you're going to have a quiz on unit conversion at the end of class. It's going to be the same format as last time. I'll check it until it's right, and I'll be back by the time the quiz starts. So just, be ready for that. The other thing I wanted to note before you start working on your Lego Sumo bots is I want to the rubric for the competition program. So again, the competition's next week. You're going to have to hand in your competition program. It's going to be a little bit different than your group quizzes though, because what you're going to have to do is you're going to have to describe the program inside Lego Mindstorms, and I'll go over how to do that in the next part of this video. The big thing, grammar spelling is going to be 20%. So I don't want when you do something like this and you're handing it in and you want it to be professional, you want to make sure that you spell things right and that your grammar is correct. So that's going to be 20% of your grade. 40% of your grade is going to be program creativity. So if you use the exact copy of one of the group quizzes, that's not being creative. I want you to think outside the box a little bit. If you modify the group quizzes just a little bit, then you know, that's a little bit creative, so you'll be developing there. But what I really want is I want originality is readily apparent in the program, and the group has displayed real ingenuity in their approach. For example, you did something with the touch sensor and the light sensor already. If you do something with the touch sensor, the light sensor, and you add the ultrasonic sensor in somehow, that might be originality. Or if you have something with the touch sensor and something with the light sensor and you program it in a different way, that's original. So think about how you can be a little more original from the group quizzes and for your competition program. The other 40% is you're going to be describing how the program works. So what I want you to do is make notes in the Mindstorm file and of how your program's working. And I want you to describe exactly how the program works and describe each block or set of blocks in the program and how they contribute to make the program work. So let me go ahead and bring up my Lego Mindstorms and show you what I'm looking for. So here's an example of a square program where we have going straight, then turning, and looping infinitely. So this will move in a square as long as the turn's correct, which it might not be here. But to sort of comment this out, what you want to do is you want to go ahead and use the comment tool, which is this little sort of speech bubble here. And then you can comment anywhere in the program. So a good idea for programming is to sort of at the top make like a general description of the program. So what I'm going to say is this program makes the robot go in a square for an infinite amount of time. And then what you want to try to describe is maybe you want to, the easiest way I think to do it is if you label the blocks. So this is block 1, this is block 2, and this is block 3. What I would say down here is something like what the blocks do. And what I would say is number 1 goes in a straight line. 2, so maybe makes the robot go in a straight line. And then number 2 would be makes the robot turn 90 degrees. And then number 3 would be repeats number 1 and 2. So what this is saying is, you know, it shows you what each of the blocks do. And if you could, to make it a little easier for yourself, you could say if you have sort of a set of blocks that do something, in particular, maybe finds the black line on the edge and turns around, then that's okay. You can put like this set of blocks does that. And this is just sort of an example. But what I really want you to have is sort of a description of the program in the top of what the full program does, and then a description of sort of each block or each block set and how they contribute to what the program does as a whole. So that's basically it. So go ahead and start working on your Lego Sumo robots, and when I get back, we'll have the unit conversion quiz. All right, bye-bye.